Hello, this is the luckiest maths teacher in the world. Thanks for watching as we go through outliers. Now, you would have heard of these before. Outliers are scores that are a long way above or below the rest of the data. They're scores that basically stand out. So let's say I don't know, gave you a maths question and I timed how many seconds it took for you to complete it. So I might have the data, someone took 6 seconds, 8, 9, 10, and 16 seconds. So you might or might not think that 16 is an outlier. What does it mean really if it's a long way above or a long way below? Up until now, we've just looked at outliers. We've just looked at the data and said, oh yeah, that looks like an outlier or it doesn't look like an outlier. But now we're going to go through a mathematical definition. So we're giving you a test that you can use and it'll definitively tell you whether a score is an outlier or not. So a score is an outlier if it is less than Q1, the first quartile of the data set, minus 1.5 times the interquartile range, or it is greater than Q3, the third quartile, plus 1.5 times the interquartile range. So obviously a score couldn't be both of these. So if just one of these is true, then it is an outlier. And note that it's less than or greater than. It's not less than or equal to or greater than or equal to. So we're going to use this test on the data set above to determine whether there are any outliers. 16 might look like an outlier, but now we're going to definitively test that. So in this data set above, 6, 8, 9, 10, 16, there are obviously 5 scores. So remember, to find quartiles, you have to split the groups up. So what we do is we find the median. Now, because the median is one of the scores, when we're splitting the groups up, we don't include it. So the top half, it's not exactly half the data, but the top half is just the data 10, 16, and the bottom half is 6, 8. So Q1 will be the median of the lower set of data, so it will be the average of 6 and 8, halfway between them. Q3 will be the average of 10 and 16, halfway between them. So Q1 is 7, Q3 is 13, and so the interquartile range is just Q3 minus Q1, which is 6. So 1.5 times the interquartile range, 1.5 interquartile ranges, is 6 times 1.5, which is 9. So what does this mean? Why did I do all these calculations? So what it means is a score is an outlier if it is less than 7 minus 1.5 times the interquartile range, so Q1 minus 1.5 times the interquartile range. So that's minus 2. So a score is only an outlier at the bottom if it's less than minus 2. And none of the scores in the data set were less than minus 2. So at the other end, we look at Q3 plus 1.5 times the interquartile range. Now, if we do that, we get 22. So a score is an outlier in this data set if it's less than minus 2 or it's more than 22. And since none of the data points, none of the scores are less than minus 2 or greater than 22, we conclude there are no outliers in this data set. So now we have a definitive way to determine whether or not there are outliers. We don't just have to look at the data and take a guess. All right, so what do outliers mean for summary statistics? We'll go through that now. Please pause and copy down if you need this information. So let's look at this data set again, 6, 8, 9, 10, and 16. So we determined just then that there were no outliers in this data set. So let's say I want to calculate some summary statistics. So the mean, I just add them all up, divide by how many there are. And that's my mean. The median of this data set, well, that's obvious. It's just the third data point. Remember, if you're stuck with median, n is the number of scores, n plus 1 over 2, that gives you the number of the score that's the median. So the median here is 9. There are 2 scores below it and 2 scores above it, okay? There is actually no mode in this data set. Okay, now we can calculate some summary statistics. We already figured out that the interquartile range was 9. We know the actual range is highest, 16 minus 6, which gives us 10. I won't calculate the standard deviation on this one, but I've come up with 5 summary statistics. The first 3 measures of central tendency and the last 2 are measures of spread. Now look what happens if I add an outlier. So I'm going to add this number 200. It'll definitely be an outlier. If I applied the test, it would definitely be more than 1.5 times the interquartile range above Q3, okay? We can quickly check that. So if I now have 6 data points, Q1 is now 8, Q2 is 16, interquartile range is 16 minus 8, which gives me 8. So now any data point that is above Q3, sorry, this should say Q3 up here, any data point that is above Q3 plus 1.5 times the interquartile range is an outlier. So anything above 28 is an outlier, 200 is clearly above 28. So I've just proved that I have added an outlier to this data set. Now let's recalculate some of these statistics. So the new mean, well, they added up to 49 before, they'll now add up to 249, and there are 6 of those scores. So the mean has gone up to 41.5. The median will be the average of the 2 scores. So if I want to use my formula up here, there are now 6 scores. 6 plus 1 on 2 is 3.5. It means the median will be the average of the 3rd and the 4th scores. So it's 9 plus 10 over 2, which is 9.5. So the mode hasn't changed. There's still no mode because no scores are repeated. I just figured out before that the interquartile range is now 8. The range is now 200 minus 6, which is 194. So what I'm doing is showing you the effective outliers on summary statistics. So you can see that the mean, by adding this outlier, has gone up a lot. Means are very susceptible to outliers. If there is a score that's a long way above the rest, it drags the mean up significantly. If there's a score that's a long way below the rest of the scores, it drags the mean down significantly. So means are susceptible to outliers. But in this example, we see the median hasn't changed much, okay? It's gone from 9 to 9.5. So adding a huge score didn't change the median a lot. Medians are not susceptible to outliers, nor are modes. Outliers don't have an effect on modes. The interquartile range, now a measure of spread, it didn't change much. It went from 9 to 8. Didn't change much at all, but the range has changed a lot. So what we're saying here is I have all these summary statistics. I want to look at when it's better to use them. So if the data has a lot of outliers or it is skewed, then that means it's best to use the median over the mean because the median is less affected by outliers. So I want to use the median and also the interquartile range. So the median's probably the best measure of central tendency and the interquartile range, the best measure of spread. So if I'm comparing 2 sets of data, I want to compare these 2 statistics rather than say the mean or the range. Now I alluded to this in a previous video. I told you about, say, when we are reporting on house prices. People usually don't report the mean house price because the data is skewed. There are quite a number of houses that cost, relatively similar amount, but then there's a small number of absolute mansions that cost millions and millions of dollars. They would drag up the mean, and so if we talk about the mean house price, it wouldn't really be useful. It wouldn't give us a good indicator of what the average or normal house costs. We always report on the median house price because the data is skewed and there are outliers. So whenever data is skewed or there are outliers, you use the median or the interquartile range. If there are no outliers and the data is not skewed, usually we compare means. And you can use like the standard deviation for that, because the standard deviation is also affected by outliers. You can use the range as well if you want for a quick one. So just a quick word, why is this the case? The reason is about which data points are used in the calculation. So when I'm calculating the mean, I add up all data points. So in my calculation for the mean, I take into account every single score. The median only takes into account either the middle score or the middle two scores. It doesn't care about, it doesn't take into account outliers, scores that are on either end. That's the same down here with the measures of spread. So the range only includes the largest and smallest numbers. So if there are any outliers, they will be included in the calculation for range. Similarly, for standard deviation, we include all data points in that calculation. So if there are outliers, they will affect the calculation. The interquartile range only includes Q1 and Q3. It doesn't include outliers because it doesn't include the top 25% or the bottom 25% of scores. So that's why it isn't susceptible to outliers. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.